Network troubleshooting using Wireshark.
Today, we're going to be talking about DNS exfiltration. Before we start, disclaimer, this video is for educational purposes. So you as an IT networking expert or security expert have an idea at just how easy it is to use the DNS protocol to exfiltrate data. So want to just be very clear about that. This is for educational purposes, and hopefully this illuminates or sheds some light on some of the security vulnerabilities you may have in your network, especially enterprise level grade networks. So what is DNS exfiltration? So the DNS protocol, as we know, is the effectively the directory protocol in networking. DNS allows you to resolve things like IP addresses to host names and host names to IP addresses. Allows you to find the IPs of mail servers for when you're trying to email someone, etc. Generally speaking, DNS is permitted on firewalls going out to the internet for obvious purposes. You need people to be able to resolve the host names of various services they're connecting to within your network. And so you let DNS go through the firewall. The problem being is that DNS is plain text, and DNS is generally not inspected. So here's the scenario we have here. We have a PC within a corporate network trying to resolve DNS from an external name server. There's a firewall involved. This firewall may be a simple firewall, just doing SPI. It may be a firewall doing some kind of next generation analysis and threat detection like a Palo Alto. To be honest, I've done this test on enterprise grade firewalls and I've been able to exfiltrate data without an issue. But the firewall is there. And then on the outside, there is a remote server that is listening for the DNS traffic. So the way a DNS exfiltration attack works is that a malicious user within a secure zone, so in this case, say it's within an enterprise network, wants to send data to a third party outside the company without being detected. Normally, things like HTTP traffic and web traffic, they go through proxies in an enterprise network, which have things like DLP, which is data loss prevention mechanisms, to be able to inspect what you're doing and what you're posting to different sites and things like that and record all of that. So usually, if you're trying to do something through that means, it'll be detected right away. If not right away, it'll be recorded so that if they detect it later, they can go and take action against that employee. With DNS, it's a little bit more permissible. Now, some companies operate their own DNS infrastructure, meaning you don't communicate directly with outside DNS like this. You communicate with the DNS server within the network, and then that DNS server then communicates to the internet. But either way, generally, the firewall rules controlling that traffic are usually permissible, in my experience. So either the DNS servers internally can access out any DNS server outside, or any PC within the organization can access any DNS server outside. So that being said, that is why DNS exfiltration is so powerful, is you have the ability to construct DNS packets, inject any sort of text, send them out, and to the firewall and to anyone looking, it looks like a regular DNS query going to a remote server. The difference being, though, is that in DNS exfiltration, you don't get a response back, or you don't need a response back from the server, right? You just send the packet out, a UDP port 53 packet. The firewall, again, will permit it, thinking it's DNS, and then it's received by some remote entity who will basically sniff it up and start recompiling that text data into something that you need. This doesn't also have to be text data. I've seen versions of this where they take any sort of file, they break it down into hex or binary, and then transmit that within the DNS payload, and then they have a mechanism on the remote side to actually reconstruct that. So there's lots of flavors of this. What I'm going to show you is very simple. We're going to use ChatGPT to whip up a script to do DNS exfiltration. We're going to use Wireshark to be able to show you what it looks like when that text is actually being sent through DNS, and actually hopefully be able to detect some of this in case you are on the defensive side of this. You see a packet capture and you think maybe there's some data being sent out to the internet or to a third party through DNS. And the reason I'm using ChatGPT is, one, it saves me time, but two, to just show you how simple this is and really how dangerous this kind of threat is if you're really worried about data exfiltration. So without further ado, let's go to ChatGPT. Okay, so I'm over here in ChatGPT. We're going to use Python for this. So let's start with my prompt. So please, I always say please write a Python script to allow me to send the contents of a text variable in using the DNS protocol. The text should be broken into chunks and embedded into a field within the DNS query. If the text is too long for the max payload size, get into multiple packets. Script should allow me to specify the destination DNS server and should send the text 10 times in a row. We should do this just so we can make sure the text actually gets out. One more thing I'm going to specify is please do not use the DNS Python library for this. I've had issues with that in the past. If you didn't specify that, you would just go through the same problems I've had doing that, but I don't want to use DNS Python. So let's see what it does. We've got a script being generated. I think by default it will generate it for Python 3, but we're going to find out. Perfect. Okay. Make sure to replace the transaction ID, generation, and DNS server variable with your own randomization and desired DNS server details, respectively. Please keep in mind that embedding data in DNS queries is, and I don't know what the rest of that is, so I'm going to ignore that. Let's copy it out. Let's go over to VS Code. I have a file here, dns.py. Let's paste it in. Let's save it. So looks like this is the sending function. Looks like this is the construction of the packet function. Looks like here's the text, and here's the DNS server. So we'll leave it at Google. That's fine. Or, you know what, let's change this to a server. This would be the server, if you were the attacker in this case, the server that you have somewhere on the public internet, say, where you are collecting the data. So let's just say this is 1.2.3.4. For this demonstration, it doesn't matter. But that's what that IP would be. And the text, this is the text that we sent over DNS. Let's add to that. We are exfiltrating data using ChatGPT and Python. Secrets, data, passwords, etc., etc. Okay. All right, let's see if this works. So I'm on a Windows machine, so we're going to open up PowerShell. Oh, this is a frozen one. Let's get a new PowerShell. And we are going to go to scripts, Python DNS.py. Now, before I run that, I'm going to start up Wireshark on the Ethernet interface, and I'm going to type UDP port 53 for DNS. Come back to PowerShell and run the script. So I didn't ask ChatGPT to make this interactive. The DNS query is timing out. That's great. Let's take a look. So right away, you can see the text in the dissection in the info field in Wireshark. Now, this may not seem revolutionary to you, but if you know network security, the number of firewalls out there that can actually read the DNS queries as they're being sent through the firewall and actually pick up that this data is sensitive data, it is, I could say, tiny. Like the number of vendors out there and software versions that can do this is tiny. And this is plain text, right? Like I didn't do anything fancy. I already have a mechanism here to actually send this traffic out to the internet in plain text. I'm not even trying to hide it. But I can tell you from experience that this in itself is something that most organizations would not be able to detect. You can see here some legitimate DNS traffic, right? Battlenet. We see the query going out and the response coming back from the DNS server. In this case, the responses aren't coming back, but who cares? Because all that matters is that we are sending out the packet 1234 or whatever the IP or host name of the server is that we have is on the other side. And you can see how easy it is for that server to be able to grab this data and actually understand the text you're sending, right? They don't have to send the response back. On this server here, you could just run Wireshark or TCP dump to just collect all the raw data and then process it later. You can actually do a script to be able to interpret that data and put it together. But you could get a little bit more creative. So let's do something a little bit more advanced to see if you can actually hide this data a little bit better. Okay, so let's start again. I'm going to use the same prompt. Okay. I'm going to add to this to say, allow me to specify a passphrase and encrypt the contents of each payload using a hash. Okay. I'm going to do simple hash because I don't want to have Python dependencies spun up that I don't have and are going to be complicated. And again, do not use DNS Python for this. So let's see what happens. So really, the only difference here is we're doing the exact same method of sending out DNS packets with the payload of our sensitive data, but now we're just going to actually be hashing that data so that in case anyone does pick up on the fact that we're doing that, they're not going to be able to see the data. So let's copy that code. Let's go into VS Code. Save it. Looks like hashlib is here. Let's see if I have hashlib. I hope I do. Let's do, make sure Wireshark is going. Again, I've lost my interfaces, so let's actually close Wireshark. And they're back. Ethernet, UDP, port 53. And let's go to PowerShell, Python, DNS, Py. Okay, so I didn't actually take a look at the script, but let's see what they put in here. Okay, perfect. So DNS server is 8.8.8.8. The passphrase is my secret pass, 10 repetitions, chunk size of 50, and we're doing lorem ipsum again. Okay. So let's see if this is actually that query. I think it actually is. Let's see what's in here. Standard query. Query example. I don't see it. Let's actually look at the follow the packet UDP stream. Ah! And there it is. So this piece of text here is actually a hash. Let's see what they are using for it. I'm assuming it's MD5, but certainly a hash. Let's see if we can run it again. PowerShell is a little bit annoying as you can't actually escape character easily, but let's just open a new PowerShell. Let's do C plain text. Python DNS.py. Wireshark still going. Do. Let's see if we have anything else going 8888. Here it is. Let's follow the UDP stream. Again, encrypted data. Now, there's a lot of work you would have to do to create a script to be able to extract the data and actually decrypt it, but you could see how trivial that would be. Like that's maybe half an hour worth of work with ChatGPT and Python. So that is another flavor of this. Again, if you want to get fancy, you could actually do this and encrypt the data so you don't even see what's going on. I want to do one more version of this that's a touch more advanced, but it is even more, I would say, deceptive when it comes to actually exfiltrating data. Okay, final version. This is the boss version. We're going to use the same prompt one more time. I'm going to take away the passphrase piece. I don't want to do that. Now what I'm going to ask it to do is a little bit different. Now I actually want to masquerade these queries as if they were actual DNS queries. So I'm going to take this piece of text. I wanted to break down that piece of text, that sentence, into individual words, and then I want to send those as if they were DNS queries to the server, even though those names are bogus. So let's figure out how we can actually get ChatGPT to do that. So let's say the text should be broken into individual words, and those words should be used as the query of each DNS, is the query field of each DNS packet. For example, it's good to give ChatGPT examples. The sentence or the text string, my dog is fat, should be sent as 4 DNS queries, colon, query my dot google.com, query dog.google.com, query is.google.com, query fat.google.com. So you can see if this actually does this, it's even harder to tell that my dog is fat is a sentence that you're exfiltrating. Right? This just looks like someone querying Google for a bunch of random domain names. And again, do not use DNS Python. So let's see what happens. Now, if it actually does this the first time, without me having to play with this, it's going to be pretty remarkable, right? Finally, we have remember to exercise caution to ensure you have appropriate permissions when conducting any network activities. I think it knows that what I'm trying to do with this script. So let's copy the code. I'm going to look at the code quickly in VS Code. So we have some timeout variables here. We're going to split. Okay. My dog is fat is the text it's using. 8888, that's fine. Let's see if it does it. So make sure Wireshark is still running. It's still running. I'm just going to clear this query. I'm going to restart. We're going to go to PowerShell. This PowerShell is frozen. Let's get another one going. Here we are. And we're going to go to let's go back to our Wireshark, and there's a query. Questions 1, standard query. Didn't work. Unknown extended label. So let's see if we can actually get. Actually, you know what? Let's open it up. Follow UDP stream. Well, there it is. So it did it. my.google.com is there. I didn't get the dog yet because we don't get a response, so I'm assuming dog is going to be the next sentence. But you can see how that is a little bit more subtle, right? I would have to play with ChatGPT a little bit more to get it to actually embed this into the actual query field properly. But again, that's just a little bit more work. It's not that much. You can see hasn't sent the next one yet, but let's see if it's timed out. Not yet, but it'll send the next one. We can play with it a little bit more to actually get this to work properly. But yeah, mygoogle.com. And again, most firewalls aren't going to pick this up. If you have a really, really incredible SOC team, they've got DNS query analytics running. They could sense weird patterns and queries, but you can always do things like, I'm going to exfiltrate data. I'm not going to send a million queries all at once because that'll be detected. You could send this on a timer, so it's only sending like a few queries every hour. You can randomize it, so it's sending queries as if you were doing a regular activity on your PC, et cetera, et cetera. There's lots of variations of this. And again, I'm going to bring it back to the original scenario. We're not showing you this to say, hey, go ahead and do this right away. This is educational so that you know, if you are someone who manages this piece, for example, that this technology is incredibly easy. If someone isn't available to install these tools, if they have any sort of ability to run Python, they can write this tool like very, very quickly. So you got to think about some intelligent ways of actually how to mitigate that. I'm not going to go into mitigation techniques in this video, but hopefully you have a better understanding of what DNS exfiltration is, how it actually is done in a very simplistic way, and how people today can use ChatGPT to actually do it in minutes and not really have to download or purchase a tool. That's it for this video. I hope you found this video useful. If so, please like and subscribe. Also, if you have an issue that you're working on and you would like to review the capture on the channel or get some advice, feel free to post a link to it below with the description, and I'll get back to you as soon as I can. Until next time.